You already know why ice is slippery. Your weight presses down on the ice, the pressure melts a thin layer right under your foot, and you're gliding on a microscopic film of water. It's the explanation that's been in textbooks for over a century. There's just one problem with it. It's wrong. The idea traces back to the 1850s, to physicist Michael Faraday, who noticed something strange about ice on its own. 2 blocks of ice pressed together would fuse, even without freezing temperatures pushing them there. Later scientists connected this to skating, and the pressure melting explanation was born. Ice has a rare property where added pressure actually lowers its melting point. So the story made sense. A skater's weight, concentrated onto a thin blade, should generate enough pressure to melt a sliver of ice into water. But when scientists actually ran the numbers, the explanation fell apart. The pressure a person exerts while skating is nowhere near enough to melt ice at normal winter temperatures. You'd need pressure so extreme, it's not physically achievable by a human standing on a blade. And here's the detail that really breaks the old story. Ice is still slippery even when you're not applying any pressure at all. Just touching it lightly, no skates, no weight concentrated on a point, still slick. Pressure melting can't explain that.
So if it's not pressure, what is it? The real answer starts at the surface of the ice itself. Even well below freezing, the outermost layer of an ice crystal doesn't behave like the solid ice underneath it. The molecules at the surface are less tightly bound, more disordered, closer to how they'd behave in liquid water. Scientists call this a quasi-liquid layer, and it exists on ice naturally, with no pressure required. It's only a few molecules thick, but that's enough to dramatically reduce friction. There's a second factor working alongside it. As you move across ice, friction generates a small amount of heat, and that heat can melt an even thinner film right at the point of contact. So the current understanding isn't a single clean explanation. It's a combination, a naturally slippery quasi-liquid surface plus friction-generated melting working together, with researchers still debating exactly how much each one contributes under different conditions. This is still an active area of physics. New studies keep adjusting the ratio, testing ice at different temperatures, different speeds, different surfaces. Some experiments even suggest the balance shifts depending on how cold the ice actually is, with pure surface pre-melting dominating at temperatures closer to freezing and friction playing a larger role as it gets colder. Nobody's claiming to have the final word. So the next time you catch yourself explaining ice with the pressure melting story, know that you're repeating a hypothesis that sounded reasonable in the 1800s and stuck around far longer than the evidence supported. The real explanation isn't about your body weight at all. It's about a strange, ever-present, molecule-thin layer of near liquid sitting on top of every piece of ice, whether anyone's standing on it or not. Ice was never simply frozen water with a temporary loophole. It's a solid that's quietly, permanently, a little bit liquid on the outside.